Hi everyone, welcome back. Here we are moving into the last 2 weeks of the semester. Um, Today we're going to start the topic perfect competition. So this is a little chart and I'm going to post this for you separately in Blackboard, but this can help you organize your thoughts over these last 2 weeks. So this week we're going to talk about competitive markets, and that includes the most competitive one, that's over here, perfect competition. And then this is a bit of a spectrum as you move to the right. On the other end, the least competitive would be monopoly. But then this week we'll talk about the more competitive ones, perfect competition and monopolistic competition. And then the last week we'll talk about oligopoly and monopoly, the lesser competitive market structures. And for each one of these, we'll talk about the number of firms, the type of products, and the barriers to entry. Those are the three characteristics that we'll talk about for each market structure. And then we'll ultimately see what does that mean for long run profit efficiency considerations, and what are the relevant graphs or methods for thinking about that market. So let's get started. Perfect competition, or sometimes referred to as perfectly competitive markets. This is the one endpoint on that spectrum. And the three characteristics, the number of firms, we're going to say there's a large number of small firms. Right, so lots of firms. Type of product, identical products or product. Some people refer to this as homogeneous products. That is, it's all the same. That's supposed to be the right bracket there. I can fix that. There we go. That's better. So a large number of firms, identical products, and the last characteristic has to do with barriers to entry, and they're going to be low. So low barriers to entry. Nothing especially difficult, nothing unusually challenging about getting into this particular industry. Starting any business, involves risk and takes some capital, and it's not easy. But perfect competition has very low barriers to entry. If you're willing to take on some risk, it's the sort of thing that most anybody could get into if they wanted to. So, in the real world, I think perfect competition is fairly rare, but there are some industries that approach it, that are close. Some of those are agricultural products. So there may be lots and lots and lots of farmers across the Midwest who grow grade A winter wheat. And the grade A winter wheat that you get from one farmer is going to be pretty darn similar to what you get from any number of other farmers. And I realize that farms are consolidating and that there are many big, commercial or like industrial farms. But still, there's still a large number of individuals, individual families, individual businesses in farming. They grow pretty much the same thing, and it is still possible to get started in that industry. But it is, as land gets more expensive, it is still difficult. Maybe a little closer to home, I sometimes use the example of snowplows. How many different companies plow driveways, in the wintertime? Well, so around Rochester, there might be lots and lots of small firms that will plow your driveway. They all provide essentially the same service. And what are the barriers to entry? Is there anything that makes it exceedingly difficult to get started? It takes capital, it takes on some risk, but for 8 or 10 grand, you can probably buy a used rig and get started in that business, right? And that's the kind of money that many people, can borrow or scrape together, or get some investors and get started in. So that might be one example of something that's approaches the perfectly competitive market. So let me change colors here to make one other note. In this situation, where you have a large number of small firms producing exactly the same good in a market with low barriers to entry, that makes them what we refer to as a price taker. That is, they cannot influence the market price. Right? So can't influence the market price. If they're going to plow your driveway, they can charge whatever the going rate is. They can't charge a lot more than that because no one would hire them, because there's a whole bunch of other people who would plow it for the going rate. And they could charge less than that if they wanted to, but there's not a lot of incentive to do that because they can charge, the going rate and plow as many driveways as they want. That's the takeaway there. So here's what it looks like on the graph. Change colors here. In perfect competition, and in this market structure only, we have two graphs side by side, and they're both price and quantity graphs. So I'm going to label them. There's the origin, price, quantity. There's the origin, price, quantity. But we have one for the market and one for the representative firm. And so the market graph looks pretty similar to what you're familiar with from lots of other examples in the supply and demand, section. You have a market supply curve, a market demand curve. There's an equilibrium, and so there's an equilibrium price and an equilibrium quantity. But that's in the overall market. Now, this is a perfectly competitive market, so there's a whole bunch of small firms all doing exactly the same thing in a world with low barriers to entry. And so we said that they are price takers, right? We said that up above there. So if they're price takers, then the demand for any one of their goods or services is actually very, very elastic, like super elastic. People are infinitely sensitive to price. And so what that means is, and this is unusual, right? This is the only place where you'll see this, the only market structure. That means for the representative firm, we said they're a price taker. That means they can sell at the market price, but they can't charge anything higher. If they try to charge anything higher than that going market price, no one will buy from them. Why? Because there's a huge number of a huge number of other firms producing an identical good or service, and they'll sell it at the market price. So in this case, the demand for their individual product is perfectly elastic. So that's the demand curve. Now, the market demand curve over here on the left graph, right? The market demand curve is downward sloping. But there's so many small firms all making identical products that the demand curve for any one firm is perfectly elastic. It's horizontal at the market price. So that is your demand curve. Right? So for the firm, it is this horizontal line, horizontal demand curve at the market price. Right? You pull that from the graph on the left. Now, the representative firm here can sell as many units as they want at that price. And so if they sell one more unit, they can charge that price. They sell one more unit, they can charge that price. They sell one more unit, they can charge that price. That means for every unit they sell, they bring in that money. So it's also the marginal revenue curve. So we label that demand equals marginal revenue. That is also unique to perfect competition. When we look in a video or two, when we look at monopolistic competition and we look at monopoly, that's not the case. The demand curve won't be horizontal, and it will not be equal to the marginal revenue. But here that is the case. Demand equals marginal revenue. It's a horizontal curve. So that's our starting point. Now, how does the representative firm decide how much to produce? We said they can sell as much as they want at the going market price. But how do they decide how much to sell? Well, what they want to maximize is profit. And so what we need here is the profit maximizing rule. So what we call the profit maximizing rule, and so there's pi for profit, right? The profit maximizing rule, this is going to look familiar. This is a variation on something we talked about early on in terms of marginal thinking, right? And making good decisions in the margin. You're going to do something as long as the marginal revenue is greater than or equal to the marginal cost. we said early on when we thought about marginal thinking that someone does it as long as the marginal benefit's greater than or equal to the marginal cost, right? When they become equal, you stop. That's also true here, except the marginal benefit to a firm for producing something is the revenue it can make from selling it. So we simplify and say marginal revenue equals marginal cost. This is the profit maximizing rule. And that's actually the same across all the market structures. So we can add in the marginal cost curve, and then we can find the profit maximizing output level for the firm. So I'm going to add the marginal cost curve in here. Turns out the marginal cost is usually upward sloping, and it may decrease at first, but ultimately it goes up. The marginal cost curve is going to often look like more or less the bottom of a Nike swoosh, if that helps you. There's our marginal cost curve. Now, if we follow the profit maximizing rule, you'll produce as long as marginal revenue is greater than or equal to marginal cost, and where they're equal, you stop. And so Q star for the firm is right here. So I use a lowercase q out of convention because that's representative for one firm. Over here we used a capital Q in the marketplace because that represents the whole larger market. I won't be too picky about uppercase or lowercase, but I'm just telling you that's sort of the convention. So the optimal output level, the profit maximizing output level for the representative firm is at this point where marginal cost equals marginal revenue. So there we are. We got this far. I guess if there are questions, you're going to have to email me, right, or swing by the Zoom office hours. Also look in the book, and I'm going to post some other videos to check that out. But I want to get to our next question, which is this representative firm actually earning a profit? Well, let's see. Is there a profit? Right, that's sort of our next question. Let me put that here. Well, for that we need a little bit more information, but let me catch up by redrawing where we were here. Right, so here's the whole market, and here's the representative firm. There we go. So there's our downward sloping demand curve in the market. That gives us the equilibrium quantity. Here's the equilibrium price in the market. This is perfect competition, so the representative firm is a price taker, and that becomes the demand and marginal revenue curve. Right? It's a perfectly elastic demand curve for the firm. So they're going to follow the profit maximizing rule and produce as long as marginal revenue is greater than or equal to marginal cost. There's our marginal revenue curve, but we need a marginal cost curve. Let's add that in there. There's marginal cost. That gives me Q star for the firm. Now, I want to know, is this firm earning economic profit? Well, I have the marginal cost curve, but that just tells me the cost of one more unit. So that's not the same as the average cost per unit or the total cost for producing everything. So what I need here is a little bit more information. I'm going to change color here. Let's use, let's use orange for the, so to find profit, I really need to know total revenue and total cost, or if I had either one of those divided by Q, I'd get average revenue and average cost. Either one of those would work, right? So I think profit, total revenue minus total cost. But if I divide both sides by Q, I could get profit per unit, right? Or average profit is going to be total revenue divided by Q. Well, that's just average revenue. And total cost divided by Q, that's just average total cost. Doesn't fit there, does it? So average revenue is the price you sell it for. And so since the price you sell it for is always the same, that's going to be equal to the price. So that I've got. So what I really need is my average total cost curve. So I'm going to draw in my average total cost curve like this. my average total cost curve. So notice that the average total cost curve intersects the marginal cost at the minimum on the average total cost curve. Make a note of this, sort of tuck this aside though. The marginal measure always drags the average measure along. You know this intuitively. If you have an established GPA and then you get your grades for a particular semester, if your current semester grades, that is your marginal grades, if they're higher than your overall average, that'll pull your average grade up, right? Your overall GPA goes up. If your marginal grades are higher than your average grades, it pulls your average up. What happens if you have a rough semester? If your marginal grades, your grades in a particular semester, are lower than your overall GPA, that is your average. So if your marginal is lower than your average, it'll pull your average down. Right? You understand that. Here's what it looks like graphically. When marginal cost is below average total cost is falling. And then when average total cost is increasing, that's because the marginal cost curve is above it. That means that marginal cost has to intersect the average total cost at its minimum point. So that's tuck that away. That's good that you need to understand that relationship as you draw the graphs. What we're really interested in is at Q star. We know that if the firm is going to produce it all, this is the best point for it to produce. It's at Q star. Q star, it can sell every unit at this price, right? It's a price taker, but each unit costs it on average this amount. So is that good or bad? If you are running a business, do you like it when the price you can sell it for is higher than the average cost per unit? No, that's definitely a good thing, right? That means that you're earning this much profit on each unit. And how many units are you selling? You're going to produce and sell Q star units, which means if you earn this much profit per unit on this many units, then what does this area right here represent? That's going to be what we call your economic profit. So we're going to label that economic profit. That's in that box. And so in this case, we'd say yes. In this case, this firm is earning an economic profit, and we can tell that because at Q star, the average total cost is less than the price. All right, that's a lot to chew on. I think we've gone on long enough for this video. We will pick up here in the next one and think about what happens